Okay, so let's do a few more examples of Lewis structures with just single bonds. So let's look at water. So water is dihydrogen monoxide, sorry. Which is H2O. Okay, so we are going to figure out the total valence electrons. So the total valence electrons, hydrogen, whatever that is, times 2, and then oxygen. So hydrogen has 1 valence electron. Oxygen has 6 valence electrons. So hydrogen, 1 times 2 is 2, plus 6 equals 8 total. So hydrogen I know can only make 1 bond, so hydrogen can never be in the middle. So I know oxygen is going to be in the middle, which means I will have a hydrogen on both sides with bonds connecting. So out of my 8 total valence electrons, I have used 2 4 for bonds. So that means the remaining 4 valence electrons I'm going to put so that everybody has a full outer shell. Well, hydrogen has a full outer shell with 2 electrons, so hydrogens are already full. And oxygen only has 2 4 electrons, and it wants 8. So 2 4, 6, 8. So this is the correct Lewis structure for water, where we have a full outer shell for all of the atoms involved. So that's the Lewis structure for water. Let's do one more with single bonds. This one is kind of a tricky example. I wouldn't expect you to know the name of this. It's CH2Cl2. It's called dichloromethane. You'll actually study this a little bit in one of the labs that you're going to do this quarter. So this is kind of a weird one because there are 3 different types of elements. Again, the one with the highest bonding capacity goes in the middle, which is carbon. But first, let's see what the total valence electrons are. Carbon has 4 valence electrons. Hydrogen has 1, and I have 2 hydrogens. And chlorine has 7, and I have 2 of them. So I have 4, 2, 14, which gives me 20 total valence electrons to distribute. So I'm going to go ahead and put the carbon in the middle, and then it doesn't matter the way that you orient these. I'm going to put chlorine, chlorine, hydrogen, hydrogen, but it does not matter how you orient them. Just that the carbon's in the middle. So right now I've used 2, 4, 6, 8, and now I have 12 left. Well, the carbon is happy because it has 8 valence electrons around it. The hydrogens are happy because they have 2 valence electrons around it. The chlorines are not happy because they want 8 and they only have 2. So I have I have 12 left because I have 20 and I've used 8 for bonds. So 20 total minus 8 that are bonded, which means I have 12 left. So I'm going to go ahead, 2, 4, 6, 8, 10, 12. So this is the correct Lewis structure. Carbon has a full octet, hydrogens have a full duet, which is what they want, and the chlorines have a full octet. So this is the correct Lewis structure for CH2Cl2.